Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Mr. T. Sai Krishna, and he will talk on sustainable aquaculture, RAS BIOFLOC RACEWAYS. I now request the speaker to begin. Thank you.
Thank you for the opportunity. This is Sai Krishna from Fishy Farmers Private Limited, situated in Hyderabad. So we are a startup which works on the improvement of rural economies through major agricultural transformations and natural resource management for a sustainable future. So I am an engineer from NIT Trichy, and I've started this company in the year 2018. So the journey is pretty simple. Two of our friends started this company with an investment of 17 lakhs. And the initial idea was aquaponics, the idea to grow both fish and plants using the same water. And over that year, we've experimented with a lot of plants and fish and eventually concluded that it was not economically viable. In 2019, we've received a BIRAC seed fund to improve our idea. And yes, we did improve. We started working on our filtration mechanisms in 2019. And unfortunately, in 2020, COVID hit. And after that, 2020 and 2021, the operations of the company were stalled and we just started. And during that time, we started working predominantly on manufacturing and designing of water filters. And in 2022, we've got a patent for the filtration system which we have designed, which we are incorporating now in many aquacultural units. You name it, it can be RAS, BioFloc, or RACEWAYS. So before going into the technical aspects of the subject, I would just like to show few photographs of the things which we have done over the years. So using our systems and our filtration mechanisms, we did grow venami in the fish in the tanks we have constructed. We did tilapia, pangasius, and you can see the photographs here. We've also grown leafy greens such as you can see there it's spinach and also lettuce there, butterhead lettuce to be specific. And you can see us giving the crops to the chief executive of NFDB. We have also constructed projects for the beneficiaries of NFDB. This is one such project in Vikarabad, which was constructed to the SC/ST communities, where 64 fish tanks were constructed. This is a commercial site where we have constructed the system using stainless steel tanks for trout farming. Again, these are the biofloc systems which we have constructed. This is the aquaponic systems we have come up with. And these are the fishes. As you can see, we also provide a lot of trainings to the cooperative societies and FPOs. And that's pretty much what Fishy Farmers is all about, where we supply the systems to the people and also help them grow fish. And in that aspect, we provide them end-to-end service, whatever they require. So going technically into the subject of the fish as such. So if we can take fish, it starts with an egg. The egg becomes spawn, and from spawn it becomes fry, and from fry it becomes a fingerling, and from fingerling it comes back to the harvesting size, which is some species are called as brood stock, which are then used for again laying back eggs. This is a general life cycle of a fish, and each life cycle has a very specific requirement of water flow, water quality, and every other aspect of it. So if you see from egg to spawn, that system is called a hatchery. So this system is very specific and used only for the hatching of egg into spawn. So these systems are called hatchery units. And from spawn to fingerling or spawn to fry, this stage is called a nursery stage, where the parameters of the water are not that crucial compared to the hatchery. But yes, it is still much more important than the harvesting or the grow out farms. And from fingerling to any of the harvest size, it can be half kg, 700 grams, 800 grams. This is called grow out tanks. These tanks are also can be constructed. So there are three major stages of a fish culture, where hatchery is one, nursery is the second, and the third one is grow out. So hatchery, we also develop hatcheries. Especially we have been inspired by the technology promoted by the Central Institute of Freshwater Aquaculture, SIFA, in Bhubaneswar. And we also manufacture their products like the FRP hatchery tanks, portable hatchery tanks, which are really useful for a state like Telangana, where the fingerling production is not at all there. Most of the fingerling is procured from Andhra and the near and Bengal, but there's no production of fingerlings in Telangana. So this FRP portable hatchery helps a lot to actually convert the seed to spawn and from spawn to fingerling. The next stage is the nursery stage. Again, this nursery stage, the technology is pretty much available out there. And thanks to CMFRI, Central Marine Fisheries Research Institute, which they have already developed such a model, but for a saltwater species like the pompano, we have taken the technology and rechanneled it to such a way that it can be utilized for a freshwater species and also inland. So these are the economics. A hatchery unit along with the nursery unit together can produce close to about 1 crore of fry per season. Per season, it's approximately 3 months. So what is it that we are unique in is the system which we have developed. It's called Blue Rev. So Blue Rev is a system which comes with a fish tank and a patented filter which is attached to it. The patent of the filter is mentioned here, and the filter which we have designed and manufactured, it's called a bead filter. So it has many advantage compared to the existing sand filters or charcoal filters or even drum filters. And we have installed this even in the NFDB campus of Rajendra Nagar, Hyderabad. So you can see the comparative study of a sand filter and a bead filter. So we have already been given with a patent for this filtration setup as such. So how am I promoting aquaculture? So the basic idea is to show farmer ki the amount of energy and time he spends on a paddy culture versus how much small space he can utilize to generate an income per annum. If you observe here, 1 acre for a period of 4 months, the farmer invests close to about 23,000 to 30,000. And after 4 months, after the rice or the paddy has been harvested, the maximum amount which he gets is somewhere around 38,000 to 40,000. So the difference is hardly 20,000 for an acre of land. All we are suggesting is to just put few tanks at one corner of an acre, use that water for your paddy culture, and over an year, just using 1 or 2 cents out of 1 acre land, you can generate close to about 60,000 rupees as a profit. You can see the unit economics here. So in aquaculture specifically, the highest running cost to do a fish culture is its feed. And as you can see here, 40% of the total expenditure goes towards feed. So we at Fishy Farmers are also have started manufacturing our own feed, especially for the fish like tilapia and marel in Telangana. So here also we are trying to reduce the cost incurred by the farmer. Also, this business is not very straightforward. It has many stakeholders it plays. It requires financial institutions. It requires knowledge partners like from the colleges, veterinary colleges, aquaculture colleges. We also require government agencies to support and fund these projects like NABARD, SFAC, NFDB, and the FPOs and NGOs play a major role to take this technology deep into the rural roots of India, where a farmer or an SHG can approach for a two-tank system behind his house and start generating some revenue from nothing. And what's the business idea of Fishy Farmers? Our idea is pretty simple. We provide technology to the farmer. We provide input materials like fish feed, fish seed, medicines, probiotics, and also provide training to the farmers. And we also do regular audits so that the system is running healthily. We also identify where the problem is being occurred by the farmer and try to mitigate it through our team. And this is a pretty much basic business model. And these are our products. So we manufacture UV filters, we manufacture bead filters, we manufacture oxygen cones, we manufacture tarpaulin fish tanks. They are actually HDPE fish tanks ranging from 500 to 750 GSM, and we also manufacture protein skimmers. So the services we provide, as I've told you before, we give you the entire design. We provide aeration, probiotics, fish feed. Most importantly, we provide guidance to make a detailed project report, which you can further take to the banks or the government institutes to get it registered or to get some loan or subsidy for that. And we assist you till the end. That is something which we work very persistently. And that's pretty much about Fishy Farmers or sustainable aquaculture. And thank you. Yeah.
Thank you very much, sir, for your wonderful presentation. I will take up the questions now.
Yeah.
In the meantime, can you please stop sharing the screen, sir, so that
Yeah.
we can see your full video?
Yeah, sure.
Yes, sir. I'll move on to the
Yeah.
questions now.
Yeah.
Sir, but the first question is, what are the key advantages of RAS compared to conventional pond-based aquaculture?
The answer is pretty simple. One, it uses less water. Secondly, the productivity is more. By productivity, what I mean to say is you can grow more fish for a unit amount of water compared to the traditional practices. And the third thing is the biosecurity. So once you do it in an RAS system, so you have a control on the parameters of the water, the disease aspects, the pathogens, everything. So it's pretty much in your control whether how you would like to do it. So that's very helpful with RAS systems. Yes. Yeah.
Okay. How feasible is RAS for small and medium scale farmers in
Hmm.
terms of initial investment and maintenance?
Yeah. So again, when we hear the term RAS, pretty much our visualization of RAS would be huge tanks, big filters, high energy requirement, which is pretty much true. Okay. So what I would suggest is the approach towards an RAS system should be from the market. So for example, what I'm trying to say is in Telangana, the RAS systems which we promote are specifically for the culture of a fish called snakehead marrel. Whereas the same system which we promote in Kerala is for gift tilapia. The same system in Northeast is promoted for a fish called as uh, pompano, not pompano, it's a different species of fish. So it's very important what kind of fish you want to grow, and based on that, the RAS system must be designed. And I would like to also point out that not all RAS systems are costly. What's important is for you to realize what kind of system you want to put in place. If you are growing a high value species like trout, for example, which is a cold water fish and also requires very good quality of water, for a fish like that, the RAS setup is costly because you require drum filters, bead filters, UV filters, protein skimmers, charcoal filters. All these add as a capital cost. And on top of that, they require water pump to supply the water to all these filters, which is energy intensive. But for a fish like marel or tilapia or pangasius, so these fish don't require such high levels of filtration, where only a bead filter would be good enough to go. So it's very important what kind of system you want, and even before that, what kind of fish you want to grow. And based on that, the economics can be worked, and not all RAS systems are costly. And in India, the RAS system shouldn't be costly, is what I feel, because we are competing with the local market. When we take the fish from our RAS unit and when it goes to the market, nobody labels it like an RAS grown fish. It is just a fish. So you should never forget that we are competing with the local market, and based on that, we should design our system and everything, every aspect of it. Thank you.
Okay. What are the main challenges in water quality management in RAS and how can they be overcome?
The biggest challenge in RAS units, especially related to water, is the conversion of ammonia to nitrate. This is called nitrification process. So nitrification process, though engineered very much, it's still a biological process because that's where the bacteria actually converts the ammonia to nitrate. And that conversion depends on temperature, hardness of the water, many other parameters, to be frank. So that is one key challenge to actually implement a 100% circulating RAS system, which, to be frank, in the last 8 years of my business, I haven't seen any. So what the general trend is to exchange at least 10-20% of the water to reduce the concentration of ammonia. But yeah, conversion of ammonia to nitrate is still a pretty good challenge to address. Yeah.
Okay. Could you explain how BioFloc improves sustainability and reduce input costs in aquaculture?
No, no, BioFloc doesn't reduce that BioFloc. No, so the difference between BioFloc and RAS is the bacteria which is present in the water. So in RAS systems, the bacteria which is present in water is autotrophic in nature, whereas the bacteria which is present in BioFloc's units is heterotrophic in nature. So the difference between those two bacteria is heterotrophic bacteria, which is in biofloc, thrives on carbon present in the system, whereas the autotrophic bacteria, which is present in RAS, thrives on ammonia in the system. So that's the basic difference between RAS and biofloc. And you see many biofloc tanks looking yellow in color with huge oxygenation. That's because you add carbon into the tank to make sure the heterotrophic bacteria grow, and this heterotrophic bacteria convert the ammonia into something called as floc. And as per research analysis, it is said that the flock should be eaten by the fish or the shrimp. But in true sense of economics, I haven't seen much difference because of the generation of flock. So I'm not saying biofloc is bad. I'm just saying that you should never grow a fish uh, keeping in mind that you want to grow it in biofloc or you want to grow it in RAS. Rather, grow a fish in such a way that the fish feels good about the environment it is in. So it can be RAS where say suppose the fish wants clean water, try to give it clean water. And say suppose the fish is okay with murky water, little dirty water, like say suppose like pangasius, for example, or tilapia, they are okay with dirty water. So the insist in for fish species like that, a bit of biofloc can work. But either ways, both the systems, both the things are technically very important to know. It's not just what you name them. And eventually, both the systems, the bottom line is how much is the ammonia? And that's the only question you got to answer. And if ammonia is anywhere more than 1 ppt or 1 ppm, then it's somewhere the system is not functioning. Yeah.
Okay, I'll take up the next question, sir. What are the common mistakes farmers make when starting biofloc culture, and how can they avoid them? You got my question, sir?
Yeah, I got your question. I was thinking.
Yeah, you can.
The first common mistake of farmer when he puts a biofloc unit uh, is the electricity aspect of it, because biofloc, as I told you before, the fish water tank has a lot of carbon in it, and because of lot of carbon you need continuous oxygen. So you need a blower which is running 24 by 7 for a biofloc unit. So if there is a power shortage or if there is a power cut in a system like BioFloc, the oxygen falls drastically compared to an RAS unit. And this causes the DO to drop and the fish mortality goes up. So that is something which the farmer should be very clear about. And secondly, I've put many systems and I've realized that many farmers just put not actually considering how much water they have in their ground or the ground sources or the canals they take from. So it's very important to see that you have good source of water too. Yeah, these are the 2 points: electricity and good source of water.
Okay, I'll move on to the next question, sir.
Yeah.
What type of species, fish or shrimp, are best suited for a biofloc system?
Again, as I told you, it's the market which tells you that. Okay, the market is the final sayer of all these things. But if you ask me this question, what can I grow? Yes, you can grow shrimp, you can grow tilapia, you can grow pangasius, you can grow basa, you can grow trout, you can grow marel. There are pretty much many fish species which you can grow. There's also one very important thing which you have to realize while doing biofloc or RAS is never have an intention to grow the fish to 1 kg. Okay, don't have that intention ki I'll grow till 1 kg and then sell it in the market. No, that's not going to happen, and the economics are not going to work if you do that. So it's very important ki once the fish attains a marketable size, that's somewhere around 500 grams, start selling the fish. Maybe not completely, at least start selling a small chunk of it. So as you keep selling the fish, the density of the tank, the number of fish in the tank keep reducing, and the other fish try to grow faster. So this way it will be really helpful. Yeah.
Okay. How do these modern aquaculture systems help in reducing water usage, disease risk, and feed costs?
Pardon?
How do these modern aquaculture systems help
Mhm.
in reducing water usage, disease risk, and feed costs?
Feed cost not much. The modern aquaculture systems feed cost is not much affected by that. But whereas the water reusability, because of the use of filters and all, the water is pretty much reused. And because these systems are in closed loop, you have control on the water. So basically, you know what is in the water because you're not taking water from outside. So the biosecurity of the system is quite strong. So by this, you can prevent the disease attacks. And that's why the productivity of the fish in systems like RS or BioFloc is little bit better compared to the traditional growth. Yeah.
Okay. What are the economic returns farmers can expect if they adopt these technologies sustainably?
Yeah, then again, that again depends on the market, as I've told you, because the economic returns of a system like this depends on at what price are you selling the fish. Okay, and that is something the market will tell you. For example, I can give you an example. In Telangana, we sell morel fish. The average cost of morel fish, say suppose we have grown the fish to only half kg. So if you are selling 1 kg of two pieces fish in market, the selling price is somewhere around 250 to 260 rupees. Whereas the production cost to grow that fish to half kg for 1 kg is somewhere around 160 to 170 rupees. So you almost have a margin of 80 to 100 rupees per kg of the fish production. Yeah. And that changes from place to place, market to market, species to species, pretty much. Yeah.
Okay. What kind of training
Hey,
and support?
so one second. What kind of, yes, we do provide trainings. We provide trainings in Hyderabad. We have our client sites where you can come and visit our training centers. Yeah.
Okay. What type of training and support do farmers need before adopting RAS, BioFloc, or RACEWAYS systems?
Basic know-how. That's it. Basic know-how ki what should be done, what should not be done, how to measure some water parameters. If something happens to the fish, what how to react, what to do. Basic things. You don't have to go in deep into the culture aspects of the fish, but to understand how the water is behaving, how the fish is behaving, that would be helpful. Yeah.
Okay. What role can startups and young entrepreneurs play in scaling sustainable aquaculture?
Uh, Good rule. That's all I can say. A very good rule, actually.
Okay. Sir, what advice would you give to new farmers who want to enter into sustainable aquaculture?
Start small. Simple. Don't watch YouTube videos. Don't get boggled by the numbers they are showing. Start small. Learn it. And once you get a hang of it, nobody's stopping you from expanding it. Yeah.
Okay. How can government policies and private partnerships help in making these systems more
Mhm.
affordable and
Yeah.
scalable?
There are many government policies, to be frank. They are like you can start with the central government, you can start with PMMSY, you can start with entrepreneurship model, you can start with FIDF. All these are aquacultural subsidies given by the central government. Apart from that, you also have state governments facilitating these projects. At the same time, you have NABARD who is also assisting these projects. You can also go to PMEGP, Prime Minister Employment Generation Program, with the Khadi industry is also promoting these projects. And if you are an FPO or a cooperative society or an NGO, then you also have SFAC grants and many such things which will help you put up this project.
Okay. Sir, can you tell us about yourself, your background, and what made you take an interest in this particular field?
Yeah, so as I've started, I'm an engineer from NIT Trichy. After that, I worked as a general manager in a thermal plant in Punjab for 2 years. Then I worked in PMO office as a rural development fellow for a period of 15 months. And after that, I've realized there's so much I could do to my country. So yeah, that's how I chose this field. I'm not from aquaculture, and the only thing which interested me was how can I save water or how can I get more productivity from water, and that question and that feeling of saving more water or getting more productivity out of water turned me into aquaculture. Yeah.
Okay, thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Mr. T. Sai Krishna for the talk and for answering the questions. This meeting
Thank
will
you.
now be closed. You're most welcome, sir.
Thank you.